All right, so section 2.5 is we're going to start studying compound inequalities. For some reason, kids seem to struggle a little bit with this. I think that you struggle when you try to memorize what's going on instead of just thinking about it and making it make sense in your head. So that's what I'm focusing on today. It's just that, oh, that's what that means. Okay. But think about this. We're going to talk about the difference between the words and or. So say there's some sort of giveaway, and here's who can win. You have to be a freshman and born in the month of July. So, would that make you eligible? Because if it's and, it has to be both. You have to both be a freshman. So if you're not a freshman, you're already out. And then if you are a freshman, you also have to be born in the month of July. There's not probably a lot of y'all that would apply for. Oh, sorry. However, if you put the word or in there instead of and, then that opens it up for most of y'all. Because most of y'all are freshmen. You could either be a freshman or born in the month of July. So I've got some students who aren't freshmen in Algebra 1, but if they were born in the month of July, they'd still be eligible. Okay? So that one word makes a big old difference. And we call inequalities that use the words and or, as they refer to them as compound inequalities. Okay, so if the word and is in there, what the graph is, it's the intersection of the graphs of two inequalities. So here's an example. If I said x is greater than or equal to, then we're using right here is 2. So that's from here up. X is less than 5, that's that graph. So what we're looking for is the overlap. What's in both of them? So the number 2 was in both. The number 5 was not. And then all the stuff in between is. Okay, now I'm not a fan of the way I did the graphic from the textbook. I'm not a huge fan of what it looks like, just because I don't think you need to always mark off, 1, 2, 3, 4, 5, 6, 7. I think sometimes that gets a little bit confusing. So let me show you how I'd have done it. If we're saying x is greater than or equal to, and at the same time, x is less than 5, what I'm going to do is draw a number line. I'm going to put a 0, a 2, and a 5. I just like a 0 in there to give myself a reference place. I'm going to graph the actual answer on the number line. I'm going to go down here below it and talk about these individually. Greater than or equal to 2, less than 5. So what I'm looking for is where are the numbers that are both? They've got to be 2 or bigger. And at the same time, less than 5. So is 2 in both of those? It sure is, so I'm going to include it. But everything to the left of 2 is not in the part where you're less than or greater than 2. The numbers in between 2 and 5, they're in both. So I'm definitely going to shade those in. And then when I get to 5, it didn't satisfy the second one. So I'm not going to include it. So there's my graph. Okay, now there's a much easier way of explaining what numbers you're talking about instead of using the word and on this one. Notice how 2's on the left end, 5's on the right end, and almost all the numbers I'm concerned with are in between there. And 2's less than 5, so we're going to do less than, because we're saying 2's less than these numbers, and those numbers are less than 5, but I could actually equal the 2. So this graph and this statement mean the same thing. And we prefer this one down here because it's just easier to think about. So let's try another one. Let's say I say x has to be greater than -7 and at the same time less than or equal to 10. Okay. And that's cute. We'll do above it this time so that my part that I put a box around is in here at the bottom. So 0, -7, 10. Here's the numbers bigger than negative 7. Here's the numbers 10 or smaller. Here's the numbers that are both. Negative 7 is not both. It's not bigger than negative 7. Negative 7. 10 is. It is both less than or equal to 10 and bigger than negative 7. And all those numbers in between also work. So I'm going to say negative 7. There's all the numbers that work. 10. I'm reading it left, right like a sentence. Negative 7 is less than 10. These have to turn like less thans. Don't include the negative 7. Do include the 10. Okay? All right. Now, if you do the word or, that's different because you're doing a union of the two graphs. Like, again, I put in a little clip from the book, but I think it's easier sometimes just to come out here. We'll say here's negative 2, here's positive 1. Less than or equal to negative 2, greater than 1. And I'm just saying I need it to be one or the other. So as long as it's in one of those two, it's good to go. So all of these numbers work. All of these numbers work for one or the other. So the easiest way to say it just is y is less than or equal to negative 2 or y is greater than 1. And sometimes there'll be a way of cleaning it up and making it simpler, but yeah, not here. Okay. All right. So we're going to practice some of this stuff. It says write each sentence as an inequality, graph each inequality. So a number x is greater than negative 8 and at the same time less than or equal to 4. All right. So here's negative 8. Here's 4. I want to be greater than or equal to this one. And less than or equal to that one. So I need the overlap. Well, that's from here to there, including the left end, but not including the right end. And the way we'd write that, negative 8, here's all the numbers I'm talking about, 4, put less thans, include the negative 8. That's the answer. Okay, so what numbers are we talking? Zeros and twos? Okay, so if y is at most 0, that means it's 0 or smaller. Or it's at least 2, which means it's greater than or equal to. So it's either these or those. If it's the word or, we just need one or the other. You just pile them all into one graph. And you would say it, y is less than or equal to 0 or y is greater than or equal to 2. That would be my answer. Okay, right. Compound inequalities represented by each graph. This one we're in between negative 3 and 2. Put less thans. Don't include the negative 3. Do include the 2. This one I'm in between 7 and 14. Don't include either end. Two different spots. This is going to be the word or. I'm either less than or equal to negative 7 or I'm greater than or equal to negative 4. Again, here's an or. I don't know why I went to y. I could do whatever I want. Let's go to z. Z is less than or equal to 4 or z is greater than 6. Okay? All right. Write these as an inequality. A number p is less. Okay, so we're talking 2s and 6s. You're less than 6 and at the same time greater than 2. There's the overlap. So it's just all the numbers in between 2 and 6, not including either end. Okay, or, oops, less than or equal to, or, okay, so number n is less than or equal to negative 7, or it's greater than 12. So negative 7, 12, there. That's really We're just talking about those numbers. So that's the best way I can put it. So m is more than negative 7 2/3, or at most, the number is at most, which means it's less than or equal to negative 10. So let's do this one. So there's negative 7 2/3. A little further behind is negative 10. You're either bigger than this or less than or equal to that. And just combine that's the best you can do. It's either this or this. R is not less than, which means it's greater than or equal to negative 1.5 and fewer than 9.5. Okay. So negative 1.5, 9.5. These, the place where it's both from here to there. So we're talking about those numbers right there. Okay. And then they're going to teach how to solve. Well, not they. I'm going to teach you how to solve them. There's two ways to go about this. Okay. If everything's all shoved together like this, see how there's two inequalities? Like you couldn't have an equation like that you could solve, but you can have inequalities, because what this means is this right here. Like cover up this end. It means that negative 4 is less than x minus 2, and at the same time, x minus 2 is less than 3. So if I get x over here by itself, I'd add 2 to both sides. Compare it the other way. If negative 2 is less than x, x is greater than negative 2. This one's easier. Let's just add 2 to both sides. So x is less than 5. All right, so here's what I'm talking. Negative 2, 5, I'm greater than this, less than that. The word and's in between them because both of them are happening at the same time. The numbers in between negative 2 and 5 are the numbers that make that true. So the answer to this is just anything between negative 2 and 5. Okay. So you can just convert that to use the word and go that way. Okay. There is a shortcut that I think is worth knowing. Now, the only time you can do this shortcut is real specific. That's the only part that's scary. Is like you can only do it certain times. If you just sort of ignore what's in here for a second and just think of that as a number. First off, just look at that and see if it's possible. Negative 4 less than some numbers, and those numbers being less than 3. Basically, it all boils down to, are the inequalities turning the same way? Because if they're not, then it can't work. And is that true? Negative 4 is less than 3, and you know what the numbers are. Like I can definitely work this. Okay. So notice how over here we broke it up into two different ones. We're just going to do both those things at once. Like I'm going to get the x in here all by itself, but I'm going to add 2 to both parts, just like I did over here. See how I added 2 to both of them? So really what's happening is I'm doing that. And then I'm going to go straight to the answer, which is pretty handy. Okay, so this one, I could break it up in two parts. I could say that negative 3 is less than negative 2x plus 1, and at the same time, negative 2x plus 1 is less than or equal to 9. I could do that. Or I could look and see, okay, or negative 3 is less than 9. That's true. So I know I've got some number in here between those two, and that's definitely possible. So what I'm going to do is the shortcut. I'm going to leave the negative 2 in here. Get rid of that plus 1. So I'm going to subtract 1 from everything. which gets me to here. Then I'm going to come through and I'm going to divide everything by -2. But think about what that does. That turns those inequalities. And people just like it to compare in the way where you read from left to right. So if 2 is bigger than all these numbers, which are bigger than or equal to -4, then -4 is less than or equal to all these numbers, which are less than 2. 0, -4, 2. We're talking about those numbers right there. Okay, notice if we did it this way, I'd bring the 2x to this side. 2x is less than 4, so x is less than 2, because I'm dividing both sides by +2. I actually would leave it over here, just because on inequalities it works out best. If we divide both sides by -2, it flips this. So there's what we're looking at. 0, 2, -4. I want to be less than this, and at the same time greater than or equal to that. There's the overlap. Same answer. Okay. All right, and we'll do a couple with some ors, and then we'll do a little, some that are, people will consider a little tricky. So I'm going to add 5 to both sides. Divide both sides by 3. I'm going to add 1 to both sides. Divide both sides by 2. Got the word or in between, which is huge. 0, -1, 3. Less than -1, greater than 3. If I compile those into one big pile, this is the best I can make it look. There we go. This one, 2p less than -7 minus 1. Divide both sides by +2. -2p, -1 minus 3. Got the word or in between. Divide both sides by -2 means it's going to turn that inequality. So here's where I've gotten to. P is less than -4 or it's greater than or equal to, if I graph that, oops, not 4, -4. Less than, put it all on one graph. That's the best I can do. So that describes it. All right, now sometimes you get some little tricky things going on. This is where it's all about, do I just understand what the heck I just did? If you're less than 3, less than or equal to 10, but it's got the word and in between. I need both to be true. There's the overlap. Like anything smaller than 3 makes that true. So people don't write this. That's wordy. They'll just say, oh, I'm talking about the numbers less than 3. Think about it. If a number is to be smaller than 3 and less than or equal to 10 at the same time, well, for both those things to happen, it's just got to be smaller than 3. Right? If you put the word or in there, less than 3, less than or equal to 10, then it's either could be true. So that's just all the numbers 10 or smaller. So nobody would say this. They would just say x is less than or equal to 10. Okay, and then my actual answers for the graphs. It's kind of messy. I didn't worry about getting super neat with it, but these are the actual graphs. Okay, all right, and this one, 0, 5, -7. I want to be bigger than 5, or why did I say bigger than 5? Oh my gosh. Less than 5 or greater than or equal to -7. Okay, as long as it's one or the other, we're good. All right, well, all these numbers work because they're definitely less than 5. -7's in both of them. All the stuff between -7, 5's in both of them. 5's in this one. The stuff bigger than 5's there. Okay, there's not a single number in the world that that's not true for. So we're talking all real numbers. Like every single real number there is makes that true. But if you put an and did this, okay, let's say 0, 5, -7. I want to be bigger than 5 and at the same time smaller than -7. Well, there's no solution to that. There are no numbers that are both those two things. There's no overlap. So you'd have an empty number line.